Here we have our stainless steel high pressure gauge mounts. Now when we say high pressure, these gauge mounts can take 40 bar. And 40 bar on 260 degrees. 40 bar is really the flange rating. So these are, the flange is built to ANSI 300 standard, which is 40 bar ambient, and then we drill it out to different flange standards. So you could have DIN PN 16 or table H or anything that fits on the physical flange itself. The flange is a flat face. Now this is purely because having different flange standards, it will go up against the side of the boiler gauge, so you can do multiple flange standards from the one flange. Now this, what we see here is a reflex or transparent spigot end. So it's got a graphite seal in here and the spigots would go in. But what we've done with this also is we've made different ends. So this is the drain unit here and this is the top unit. Now these can easily come off and change. So what we can do is this high pressure mount unit, so it's 316L, which is a low carbon, which is much better with steam, and we can do a borosilicate gauge mount as well. So you've got the advantage. Now you either have to choose one or the other, either a borosilicate or a reflex / transparent mount, but you can use the one gauge mount. So it gives you a stainless steel option, which is quite hard to find in a borosilicate configuration. In the borosilicate, it's just a normal EPDM gauge cone that would fit. You know, there's numerous ones that would fit in here. We've also standardized on an AB18 graphite packing, so you guys out in the field who are the service agents can use pretty much standard materials. One other difference that we went for when you compare it to another reflex or transparent gauge mount is we've made the drain assembly one piece. Usually they would save on mold feeds, they would have a top and a bottom, and purely the drain piece screws into what would be the top or the bottom of the gauge mount. Now this lets them use one mold. The disadvantage of it is you have another potential failure point if you imagined a thread in here where this drain unit goes in. So what we've done is we've molded as one piece. It eliminates a potential failure point, which is always a plus. It makes it stronger. The only disadvantage, I guess, for us is the machining is deeper, but we've overcome that. It's something that we're quite proud of. Now you can change these from a left to right easily because I've just put these on in a finger tight configuration. You would undo them and swap the top and the bottom. That would then change a left to a right or a right to a left or vice versa. So you imagine that would go on that and the top would come and it would sit on those studs. So that gives you flexibility, really easy to change the left to right. You can stock the one unit and change it to left to right as you see fit. Another thing that we've done, which is a little bit different, is we designed them to AS 1271, I believe the standard is. Now that requires a safety ball. So you do have ones with safety balls in them. Ours, the safety ball is the correct size. If you can see, it sits in here, which is above the AB18 spigot. So if you imagine the glass broke or the transparent or reflex gauge broke, this ball, the safety ball that you see in there, would be sucked up against this hex here. Now that's purely done from a pressure differential. Obviously if you have a breakage this size and you've got, let's say, 10 bar on this side, you've got a 10 bar differential which will take that safety ball directly onto the hexagonal seat. Now the reason the seat is hexagonal and not round is because the ball cannot block 100% of the flow. Otherwise, every time you blew down your reflex, transparent gauge or borosilicate glass, you would be able to blow it down and you would never get the pressure get back inside. So it's a common misconception that these safety balls block all of the flow. They shouldn't. Otherwise, when you blow your gauge down, you would never get the liquid to pass back through and equalize the pressure. So this is as per standard. As per the standard for the seat engagement around here is exactly right. Between the bottom of the mount and the top, now the top being, I guess, the bottom drain or the top part of the mount, so these two parts, you have a graphite seal in here. This is a graphite crush washer. They're easily replaced. The advantages of this is it's very high temperature and it gives you a very good seal. I guess the disadvantage is if you are replacing them out in the field and you want to get in here, you should replace the graphite crush washer every time. They're quite cheap, but they're a very effective way to seal things. So that's why we went with that. They're easy. Everything else is what you would see. We tried to use standard components and make it as long lasting and as simple as we could.